Over to you, Rafiq.
Yeah, thank you very much. I'll not take much time. I'll just first initially cover some concept of what Mukhija talked about. So I think who attended the earlier session of Munish Mukhija of G? I think more than 50%. So I think I will take on from there because he has made my job easier. And I think G being one of our biggest customer and the biggest adopter of industrial internet and what they call as predicts. We are a very, very important partner to them. And I think if you have been there for his session, my presentation is an extension of that, just a little bit more detail on what the host was talking about. Yeah. So basically, when we talk about IoT and industrial internet, I think everybody talks about IoT platform, cloud, and everything, machine learning, and everything. But I think today's session is more about the industrial internet and the role of engineering in that. And remember what Munish Mukhija said. It is the combination of analytics and physics. Yeah. So the focus of the next 5-7 minutes is on the physics part, how important physics is there. Because if you are just a consumer company and say, no, I'm going into internet, industrial internet or IoT, then it's fine, you can employ a lot of Google and Microsoft guys. But if you are a hardcore engineering and manufacturing company or a automotive company or mobile company or aircraft company, then physics plays a very, very important role, and we'll talk about that. So just imagine, I'm just taking a simple example directly to go to the concept. As you know, Facebook is trying to launch this drone, which is having a wingspan of 737, and it's supposed to be in air for about at least 3 months. And imagine the massive size it is there, and if it is of this size, then one has to take care of the weight. There's a lot of cooling, there's a lot of sensors, there's a lot of connectivity, safety, reliability. All these issues is there. And plus it's very, very heavy, correct? Solar powered and all, plus it has to beam a lot of high power gigabytes internet speed. So when we want to kind of, in today's kind of industrial internet, develop such product, which are kind of IoT enabled, then the physics plays a very, very important role. So we were talking about these challenges over here, what are the challenges products like this goes through. ANSYS has got applications, and I'm not going into, this is not about ANSYS presentation. It has got a chip package design system, antenna design, sensors, MEMS, power management, embedded software development, designing for harsh environment, and virtual prototyping. What I mean by that is ANSYS has got applications to take care of all the challenges what any industrial internet product like what we saw this Facebook drone has gone, or a G aircraft engine is going through. Yeah. So that is the only thing, and I think for each of these application, all these different kind of companies have got different advantages, including kind of increasing the bandwidth or development, reducing the time, or increasing the battery life, or increasing the antenna range, and also all these applications and usage can be covered off. Now this is the important piece we are talking about. So when we talk about Internet of Things, we talk of smart connected product, correct? When we talk about smart products, meaning there are any kind of products, like we saw this drone or G aircraft engine, then there's a platform which does a lot of analytics, and then the cloud is there. So what companies like G and Flowserve and all these manufacturing leading Bosch and all these companies have realized that, okay, data analytics or cloud computing can help you do predictive or prescriptive maintenance. Today is the time when we are talking of IoT and industrial internet. Everybody's talking of predictive and prescriptive maintenance. You know, how before the product fail, how we can kind of think ahead of time and kind of save a lot of expensive recalls, or kind of serve the customer better and have that competitive advantage. So the big data analytics or the tacit information or the historical information can help you as much as only 30%. But when it comes to physics, and when we talk about physics, once you create a digital twin, and I'll come to the concept of digital twin, very quickly, then in predictive and prescriptive maintenance, the companies will get tremendous competitive advantage. So this is a very interesting chart, that when we want to kind of move from just advanced reporting to kind of anomaly detection, and we want to actually take a leap forward into predictive and prescriptive, then I think digital twin comes in play. And I'm just giving an example. So that's the physical asset, which is the actual engine, and you have a digital twin which is there in the system, exact replica of that model. So if GE has got, say, 300 engine flyings across any moment of time in this India, then there are 300 replicas of exactly same engine there in the system. And because, as Munish Makija was explaining, based on the weather condition, the thrust, the environment, and all kind of condition, the physical load or the failure ratio or all kind of problems and issues are different for each engine. It is not the same. So then, each engine is connected through cloud, through sensor, and then of course the analytics part is there. Yeah. So what I will do is I will give you an example. So it can be another oil rigging company. So that the oil rigging company is sending a sensor which has got detected some anomaly also. So there is an IoT platform, and then there is a digital twin. In digital twin, we kind of base on because it's a physical virtual prototype model is there. We kind of do various kind of analysis, and I'll show you a live example. Then based on that simulation result, we kind of change the design parameter, and then the corrective action is given back to the field. And that's how this is a self-learning. I'll just use the word smart and self-learning system. It is just not a kind of a dumb system. The digital twin advantage is it's a self-learning, whatever applications or harsh condition or whatever the physical product is going through the environment, that information is continuously fed. The digital twin or the smart model through ANSYS simulation kind of adopts itself and gives various combination what can be the new result, and that kind of information is fed back to take the corrective action. Yeah. So let's take an example. I think we already heard about the G case study. This is more like a pump company, and the left side is the physical real world as designed, as operated with sensor testing data, all the analytics data, everything is there. Then there is the IoT platform. The IoT platform can be anything, like G uses Predix. Different companies can use different IoT platform. And then there is the digital twin or the physics-based simulation platform. Yeah. So we will see a small demonstration, and I'll just start the video. Yeah. So basically, this is a flow-serve video, hence it is not very marketing-oriented. So because flow-serve themselves had demonstrated in one of these. So this is actually your first case scenario where your pump is working. And we are trying to introduce a kind of an anomaly or a problem. You see a person is coming over there, and he's trying to change some parameters. Basically, he's trying to add some air bubbles into the system. And as people who are into engineering and manufacturing and pumps, they know that if you introduce such kind of anomaly or some kind of such errors, then there's a harsh condition, and the blade starts behaving a little bit differently, and all the efficiency parameter gets disturbed. So still now what we see is more like a analytics, okay? And then slowly analytics will predict what's going wrong and what can go wrong, but it cannot cure or it cannot give the solution. Remember that analytics, whatever smart cloud, big data analytics you're talking about, it will predict. It will say, no, I think there is a low pressure, the efficiency is going down, and there's a chance that this pump can fail. That's it. That's what but immediately we have gone to the digital twin model now, and the engineer based on the parameter, and because it's a parametric thing, two-way connected, we can change some of the, and I'm not going into a lot of the physics part over here, we can change some of the boundary condition and the model condition, and immediately we can find what is the best design solution to take care of this anomally. So, based on the different kind of situation or failure modes which are happening in the field, you can make your digital model, digital twin, smarter and smarter. So that kind of corrections have been made, and now the analytics system is also saying, okay, this looks fine and I can work on it. So you can see that through the digital model, now the digital model is getting updated, and this is the revised digital model or digital twin, which is now kind of taking care, and this is the corrective action is taken care. So in this kind of a net summary, there is a physical world, and you have all the application there, analytics is there, cloud is there, sensor is there, all the stuff is there. But if the physics and digital twin is not there, and then maybe during the panel, if the discussion comes, I will explain the concept why physics and engineering is important a little later. But to have a digital twin kind of environment, you need to have a as designed model, as operated, and then of course the IoT and cloud plays a very, very important role. Yeah. So I think this is just my concept, and I will just try to leave another concept is to make it this simpler. We have seen movie called Avatar, and there was a Rajnikant movie also, correct? Remember, after few years, we will have digital twin of ourselves also, meaning whatever action and style, and if suppose everything is captured as you have seen in Avatar movie or Rajnikant movie, even if after we are not there, if all the actions are taken care and collected, then we can have a digital twin in the system, and our family members can have interaction with us. So that is the kind of just a very simple example. But in the engineering and manufacturing world, digital twin is just, you will hear more and more about digital twin as in the coming years. So I want to leave this concept because today, in the next 2 days, you will hear a lot of things, everything about cloud, IoT, but this digital twin and physics-based industrial internet is very, very important thing.
Thank you, Rafiq. Please.